Okay, so I'm taking off here from, we're going to go through actually a couple examples of how to balance equations, and hopefully by the end of that, by the end of this this lesson, you'll have a better understanding of how to balance these chemical equations. So let me go to my Jamboard here so I can write. Um, so what I like to do when I balance chemical equations is my first step is usually to create a chart with your reactants on one side and your products on the other. So let me go ahead and do that right now. Okay, so I like to create a chart. Here we go. My reactants over here and my products over here. Okay, and I'm going to then count up the different atoms on each side. I'm going to then change the number in front coefficients of the atom. Remember, these are your subscripts. I know this is not a little one because this particular program doesn't allow me to do that. But if we go back here, okay, I can't change these subscripts. Okay, but what I can change is change a coefficient that's in front of the subscripts. Okay, and that is the number that potentially goes right in front of here. Okay. Um, so what I'm going to do first is I'm going to write off my first one. So I'm going to look at this chemical equation on my reactant side. Okay, I see that I have two hydrogen on this side, so I'm going to write hydrogen, and I am going to write a 2 here. I look on this side, and I see I only have one hydrogen on this side, so I'm going to write one hydrogen. Okay, there's no subscript, there's no coefficient, so I can assume, but the H is written. Okay, so I do have one H. Okay, and then I'm going to look at my fluorine. Okay, so hydrogen plus fluorine equals um, fluoric acid. Okay, so I'm looking at my hydrogen. I already did my hydrogen. I looked at my fluorine. Okay, fluorine, I have two fluorine on this side, and I have one fluorine on this side. Okay, this is not a balanced chemical equation, right? I have two hydrogen in my reactant side, and I have only one hydrogen in my product side. So I need to balance this. Okay, so how do I go about doing this? Well, I know I have two, so how do I turn 2 to 1? This, um, I multiply my fluoric acid by 2. Okay, that now provides me two hydrogen, and then I see that I needed two fluorine. I have two fluorine on my reactant side, and now I have two fluorine on my product side. This, when I add the two here, it's really just multiplying both atoms in that particular molecule by two. Okay, and this coefficient now allows me to have a balanced equation. I have two hydrogen on my reactant side. I have two hydrogen on my product side. I have two fluorine on my reactant side, and I have two fluorine um, on my product side. Okay. Um, Now let's look at sodium plus chloride equals sodium chloride. Okay, my first step again I like to do is create a chart with my reactants on one side and my products on another side. I have sodium, okay, and I have chlorine. Okay, so on my reactant side I have one sodium and one sodium on my product side, right? There's no subscript, there's no coefficient, so I have one and one. Beautiful, that's balanced, that's great. Okay, for chlorine, I see I have two chlorine on my reactant side, and I only have one chlorine on my product side. Okay, so how do I go about balancing this chemical equation? Well, what I'm going to have to do is make two chlorine on this side. Okay, so I've got here, I'm going to put a 2 here. Awesome, now I have two chlorine. My chlorine is balanced. Okay, but this coefficient gets multiplied not only by chlorine, but it also multiplies my sodium. Okay, so my sodium now increases. So now I have two sodium on this side. Well, how do I get two sodium on the other side? I simply put a coefficient here, and it is right there. Okay, now I have two, and now my sodium is balanced. And I know you're saying, like, what are you doing? How are you getting these sodiums? Where are you getting these sodium atoms from? Remember, these sodium atoms are coming because there's a conservation of mass. That in order for this reaction to happen, there has to be the same number of sodiums on this side of the equation as this side of the equation. It's not like I'm just throwing numbers in here. Okay, for this reaction to actually happen, Okay, I need to have the same number of sodiums on both sides of the equation, or else it will not be a full chemical equation. Okay, there might be, some extra sodiums over here, let's just say. Okay, um, and you're going to learn more about that and stoichiometry in grade 11. But for now, just know that it's you need the same number of atoms on this side as the same number of atoms on this side. Is basically what we're talking about. Okay, because if this did not fully happen, if I didn't have the same number of sodiums on this side as this side, I'd potentially be left with more sodium on this side or more chlorine on this side. Okay, but we can tell that this full reaction happened, so because there is no extra sodium on this. Okay, so the same thing. We have nitrogen and bromine. They equal nitrogen bromide. Okay, so create a chart with reactants on either side of the uh, on either side. So I have my reactants and I have my products. I'm going to create a chart. Boom. Okay, I'm going to start with my nitrogen. Nitrogen, I have 2 nitrogen on this side and I have 1 nitrogen on this side. You can see there's no subscript, so I have 1 nitrogen on this side. Okay, so let's start with nitrogen. Okay, I have 2 here, so what I'm going to do is I'm going to throw a coefficient of 2 here. Awesome, now my nitrogen is balanced. Boom. On this side I have bromine, and I have 2 bromine with a subscript of 2. I don't change my subscripts ever. But on this side I have a subscript of 3. Oh my goodness, what am I going to do? Okay, or sorry, I have a subscript of 3, but I've also multiplied. That's my fault, guys. Let me erase this. Okay, I also have a subscript of 2, and remember, when I multiply my subscript, I'm multiplying by my nitrogen and I'm multiplying my bromine. I originally had 3 bromine, and now I actually have 6 bromine, right? 2 times 3 is 6. Okay, cool. That's okay. That's not a problem. I have to now go back to my reactant side and make this bromine equal to 6 bromine atoms. How do I do that? Is I simply multiply bromine. I already have 2. I multiply it by 3. 3 times 2 is 6. So now I have 6 bromine. My nitrogen is balanced, and I have the same amount of bromine on either side of the equation. Okay, for this one, guys, it's really important, especially moving forward, that you realize that it's important to know common factors and common multiples when you're going into balancing chemical equations. Okay, this is like grade 6 or 7 math, where you need to remember, a common factor of 2 and 3 is 6. Okay, but you'll get more practice as you progress through. Okay, now let's do this one. I don't have the steps here, but I'm going to walk through the steps with you. Okay, what I like to do is I like to create a chart. I have my reactants, and then I have my products. Okay, and I'm going to start off. I have aluminum. Okay, how many aluminum do I have on my reactant side? I have 1 aluminum on my reactant side. How many aluminum do I have on my product side? Well, I have 2 aluminum on my product side. Okay, so that's not balanced. So let's balance that. How do I turn 1 aluminum to 2 aluminum? I simply multiply this single aluminum atom by 2, and now my aluminum atoms are balanced. Okay, cool. Awesome. Now I have oxygen. I have 2 oxygen on this side, and I have 3 oxygen on this side. Oh no, what do I do to balance this? Well, what I'm going to do is, I know I have 2 here, okay, and I have 3 here. A common factor between 2 and 3 is 6. So I know I need to multiply this by 3. Okay, now I'm left with 6 oxygen atoms, and I have this one by 2. Okay, cool. Now I've multiplied my 3 oxygen atoms on this side by 2 to give me 6. My oxygen is balanced. But now I've changed the coefficient in front of my aluminum here. Okay, aluminum originally had 2, and I've now multiplied that 2 by another 2, so I now have 4 aluminum atoms. Okay, and now I need to change this to a 4 as well. Okay, so I'm just going to scratch this out and put a 4 here. I'd rather you not scratch it out on tests and quizzes. It makes it hard to read. Erase it, or just do a single line through it so it makes it a little bit easier. Okay, so I have 4 aluminums and 6 oxygens, and that is a now balanced, completely balanced equation. Okay, the same number of aluminums go into the reaction, and the same number of aluminums come out of the reaction. The same number of oxygens go into the reaction, there's 6, and there's the same number of oxygens going out of the reaction of 6 as well. All right, so we're going to look at this equation, and this equation looks pretty scary and pretty daunting, but I promise you it's not that bad, okay? You would have remembered from yesterday we talked about polyatomic ions, okay? And polyatomic ions are, again, two nonmetals most of the time that form a specific atom, okay? That form a specific atom. They're together all the time. So when you're balancing chemical equations, I think I wrote it here, okay? When you're balancing chemical, oh, I didn't. So when you're balancing chemical equations, you always want to keep the polyatomic ions the same as long as they show up on both sides of the equation. So I can see that there's an NO3 on this side right here, and that is a polyatomic ion. That's nitrate. Okay, so NO3 is here. I'm going to look on this is my reactant side. I'm going to look on my product side, and I see that there's another NO3. Okay, and I'm going to keep NO3. I'm not going to separate them into different atoms. I'm going to keep it as one atom. Okay, so one atom of nitrate is right there. I also see I have a polyatomic ion of OH, hydroxide. Okay, I'm going to treat hydroxide the same here. Okay, I see that I have another hydroxide here. So I'm going to treat my hydroxides as one atom as well. So I'm treating polyatomic ions as one specific as one atom, not necessarily as separate atoms that make up one atom. I want to treat them as one atom. And you'll see this when I write my reactants and products. Okay, so I'm going to write my chart, reactants and my products. Okay, here we go. So my first reactant is calcium. It's a big calcium. So I have one calcium on this side. There's no coefficient underneath my calcium. Great, and there's one on this side. So I have one, boom, and one, boom. Balanced. Okay, I'm going to then go to my nitrate. Okay, NO3. Okay, I have two NO3s here, and you can tell that by this coefficient right here. This coefficient tells me that I have two NO3s, so two nitrate atoms. It's not two nitrogen and six oxygen, it's two nitrate atoms. So I have two nitrate atoms on this side of my equation. And I'm only writing it this far over in case I need to like add more over here. All right, and then on this side, it looks like I only have one. Okay, so I have one nitrate atom. Well, I need two nitrate atoms, so I am going to multiply this compound, sodium nitrate, by 2. Cool. Now I have a sodium nitrate that has 2. My nitrate is now at 2, and I am happy, and it is balanced. My sodium, okay, on this side I have 1 sodium, right? I only have 1. And on this side I have, how many? 1, 2, right? I've multiplied this by 2, and I've multiplied this whole ion by 2, right? This whole polyatomic ion by 2. So now I have 2 on this side. So what do I do to change sodium to balanced sodium? I'm going to put a coefficient of 2 in front of it. Okay, and now I have 2 sodium. Beautiful. Now I'm going to look at my hydroxide. Remember, it's a polyatomic ion, so I'm going to treat it as one whole atom. Okay, on this side, I now have 2 because I put a 2 in front of there. 2, and I've now put a 2 in front of there, so that's now OH is 2. And on this side, I have a coefficient of 2 underneath my hydroxide, and I have 2 OHs right there. Okay, I'm going to stop the video here, and I'm going to have another part 3 video to go over a few more examples with you. I'm just running out of time on my recording here, so bear with me. I will have part 3 coming right up.